Welcome to Dr. Sherry's Astronomy channel. The topic of this episode is the universe in stunning resolution. Today, I'll be showing you the 2026 calendar, featuring stunning images from both the James Webb and Hubble space telescopes. The European Space Agency works alongside NASA to develop and operate these incredible observatories. For the upcoming year, ESA has selected the most breathtaking images to create this official 2026 calendar. It is available as a free digital file, so anyone can print, share, and enjoy it. You can find the download link in the description below. Since the calendar doesn't include deep scientific details, I'll be giving you a quick guide to the celestial objects and the science behind them. The cover page features an image of a star-forming region in the constellation Taurus, about 525 light-years from Earth, capturing the scene where planets are being born. Captured by the James Webb Space Telescope, this image shows a protoplanetary disk enveloping a young star, known as a protostar. The protostar is in the process of growing by absorbing the surrounding gas and dust. As material is drawn in by gravity, the influence of rotation causes the components that did not fall into the center to form a flat disk. This serves as a reservoir of materials that will become planets in the future. In the image, we are viewing the disk edge on, so a dark band of dust appears in the center, blocking the light. On the other hand, the starlight scattered by dust spreads faintly above and below the disk, allowing us to see its three-dimensional structure. By observing in infrared, the James Webb Space Telescope vividly depicts the internal structure of the star birth site, which is shrouded in dust and difficult to see in visible light. The January image features NGC 346, a star cluster located within the small Magellanic Cloud. This cluster is an extremely active star-forming region, often called a star factory, where gas gathers by gravity within molecular clouds, and young stars are born one after another. Released to celebrate Hubble's 35th anniversary, this image captures its dynamic appearance using the latest data and processing techniques. The scattered blue-white dots are a group of newly born young stars. In particular, many massive stars are present, and the powerful ultraviolet light they emit ionizes the surrounding gas, dyeing the nebula with a faint light. The haze-like light spreading around is a region of gas that has been heated and ionized by starlight. Meanwhile, the dark streaks running through the image are areas where dense dust blocks the light from behind. This indicates that an abundance of material, the fuel for stars, remains there. The small Magellanic Cloud maintains an environment with fewer metals compared to the Milky Way, and it is thought to resemble the state of the universe shortly after its birth. In a low-metal environment, the way gas cools and the effects of stellar winds differ from the norm. Therefore, detailed observation of this cluster provides important clues to unlocking the fundamental mysteries of how stars were born in environments close to the early universe and how they reshaped their surroundings. The February image is the massive galaxy cluster Abell S1063, where thousands of galaxies are crowded together. Galaxy clusters are the largest structures in the universe, consisting of a vast number of galaxies bound by gravity. Beyond the visible galaxies, there exists an enormous mass of dark matter, along with high-temperature gas reaching over 10 million degrees. In this image captured by Hubble and James Webb, several thin, curved arcs of light are scattered around the golden elliptical galaxies at the center. These are not tails extending from the galaxies, rather, they are the light from even more distant galaxies, distorted and stretched by the cluster's powerful gravity. This is a phenomenon called gravitational lensing. The immense mass distorts space itself, acting like a natural telescope that magnifies and deforms objects behind it. By analyzing the degree of this distortion in detail, we can estimate the distribution of dark matter hidden within the cluster, which cannot be explained by the number of visible stars alone. Furthermore, this lensing effect makes it possible to study galaxies from the early universe in detail, objects that would normally be too distant and faint to observe. The March page features NGC 6334, popularly known as the Cat's Paw Nebula for its unique shape. Located within our Milky Way galaxy, This is a large-scale star-forming region where gas and dust are densely concentrated, and new stars are still being born. Because star birth sites are enveloped in a thick cocoon of dust, it is difficult to see the interior in detail with visible light. This is where the James Webb Space Telescope, specialized in infrared observation, proves its worth. Infrared light has the property of passing through dust, allowing us to clearly see the young stars hidden deep within the clouds, as well as the edges of cavities carved out by stellar energy. The blue-white glowing parts are regions where the surrounding gas is intensely illuminated by the light of newly born massive stars. The surrounding reddish-brown, complex filaments and membrane-like structures show how gas clouds rich in dust are dynamically changing their appearance under the influence of starlight and stellar winds. Here, the process of gravity gathering gas to create stars and the process of born stars pushing away surrounding clouds to trigger the next star formation are proceeding simultaneously. The April page features the globular cluster Messier 72, located in the direction of the constellation Aquarius. A globular cluster is a collection of hundreds of thousands of stars that are tightly pulled together by mutual gravity into a spherical shape. In contrast to the young stars scattered in the disk of the galaxy, the stars that make up globular clusters are very old, making them important subjects of research as living fossils that tell us about the early state of galaxy formation. The image vividly depicts how the stars become more intensely crowded toward the center and spread out faintly toward the outside. The extremely high density of stars in the center is evidence that, over a long period, the orbits of the stars have influenced each other, evolving into a stable, core-like structure. Also, please pay attention to the difference in the colors of the stars. Blue-white stars indicate a higher surface temperature, while reddish stars indicate a lower temperature. By analyzing the distribution of these colors, the accurate age and chemical composition of the cluster can be derived. The May page features the aurora shining in the north polar region of Jupiter, the largest planet in our solar system. This image captured by the James Webb Space Telescope clearly depicts the cosmic weather phenomenon woven by Jupiter's massive magnetic field and atmosphere. The square frame shown in the overall image on the right indicates the area where the aurora was captured in detail. In the enlarged view on the left, a strong band of emission spreads to border the polar region, and we can see that its brightness reaches an overwhelming energy hundreds of times that of Earth's auroras. Jupiter's auroras are generated when charged particles, guided by a powerful magnetic field, descend into the atmosphere and excite molecules and atoms. Jupiter has a very strong magnetic field and a vast magnetosphere. Not only the influence of the solar wind but even particles emitted from the volcanic activity of the satellite Io become the source of this massive light phenomenon. The June page features the young star cluster Pismis 24, located in the direction of the constellation Scorpius. Situated at the center of the Lobster Nebula about 5,500 light-years from Earth, this cluster is one of the most intensely active regions in the galaxy, where massive stars are being born one after another. In this image captured by James Webb, we can see how the clouds of gas and dust surrounding the cluster change their appearance moment by moment due to the overwhelming energy emitted by the stars. The flame-like orange part spreading on the left side of the image is the scene where clouds rich in dust are illuminated by the fierce radiation from the cluster, and their surfaces are intricately carved. The faint, whitish region spreading inside suggests that gas ionized by strong ultraviolet light is projecting significantly forward. On the other hand, in the dark blue region on the right, countless stars are scattered like jewels, telling us that this cluster is the dominant protagonist of the entire region. Locations where stars with massive mass are born are few in the entire universe, and their evolution is very fast, making objects that can be observed in detail, like Pismis 24, extremely precious. By passing through the veil of dust with infrared observation, the previously hidden young stars and fine density variations within the clouds have clearly emerged. The July page features the Sombrero Galaxy, located in the direction of the constellation Virgo and shining about 30 million light-years from Earth. The greatest feature of this galaxy, captured by the Hubble Space Telescope, is that it is facing almost directly edge-on from Earth's perspective. Because its unique silhouette is reminiscent of a broad-brimmed hat, it is popularly known by this nickname. The large, white glowing bulge in the center of the image is a structure called the bulge, where a vast number of stars are crowded. It is surrounded by a thin, disc-like structure, and further, a thick layer of dust within the disc blocks the light from behind, causing a single sharp and powerful dark band to emerge. In the disk part of the galaxy, gas and dust, the materials for stars, are stored in abundance, and new stars are still being formed. On the other hand, many old stars are gathered in the central bulge, telling the history of how the center of the galaxy has been nurtured over eternal time. In this way, the coexistence of a disk that continues to give birth to stars and a center that quietly marks time within a single galaxy provides an extremely important clue to unlocking the process of galaxy evolution. Capturing such an appearance is a key to unlocking the grand cosmic cycle of how star materials circulate within a galaxy and are passed on to the next generation of stars. The August page features 3 images captured at different wavelengths of NGC 6302, known as the Butterfly Nebula because its appearance looks like a butterfly with spread wings. This object is a shell of gas and dust called a planetary nebula, created when a star with a mass close to the Sun ends its life and releases its outer layer of gas into space. The 3 images captured by Hubble, James Webb, and the ALMA telescope each show a different expression. In the visible light image captured by the Hubble Space Telescope, the gas ionized by intense light from the central star vividly depicts delicate streaks, or filaments, and the outlines of the wings. In the near-infrared image, as the influence of dust is softened, countless stars sparkling in the background and the structures penetrating the interior of the nebula are highlighted. And the image on the right is a large enlargement of the center, featuring the distribution of warm dust and molecular gas as the main subject. Behind the beautiful butterfly shape of this nebula, it is thought that a disc-like structure where dust is densely concentrated exists near the center. Infrared and submillimeter waves, a type of radio wave, are excellent at capturing this skeleton of dust and molecular gas. By looking at the 3 images side by side, you can feel how the things visible change dramatically depending on the wavelength. The glow of gas, the dust that blocks light, and the molecules that show the 3-dimensional structure. By overlaying and interpreting these, we can more deeply and closely feel the story of the magnificent formation depicted by the end of a star. The September page features an image of a section of the Eagle Nebula, Messier 16, captured by the Hubble Space Telescope. This region is at a distance of about 7,000 light-years from Earth, and the structure of gas and dust spreading across the image spans approximately 9.5 light-years in length. The appearance, like a towering tower standing in the abyss of space, is truly a magnificent sculpture created by nature. This pillar-like structure appears as the dense parts that were originally in the clouds survive while the surrounding thin gas is carved away. The role of the carver is played by the intense ultraviolet light and stellar winds emitted from massive stars born nearby. The surface of the pillar is heated by the light, and ionized gas emits a faint glow. On the other hand, the interior of the pillar emerges as a dark band like a deep shadow because the dense dust blocks the light from behind. The contrast between the bright edging and the black band seen in the image tells the story of the very boundary where starlight and dust clouds fiercely compete. Inside such pillars, even denser clumps contract by their own gravity, nurturing the next generation of stars. By carefully observing signs dwelling in these details, we will be able to unlock the laws of star birth, where star formation is promoted or hindered. The October page features the Spiral Galaxy NGC 5335, captured by the Hubble Space Telescope. Because this galaxy is in a face-on state, with its disk facing directly toward Earth, a major feature is that we can observe in detail how stars are distributed within and in what locations new stars are being born. This galaxy is classified as a flocculent spiral galaxy, and instead of having single, clear spiral arms, It has a unique appearance where small arm fragments appear to be connected like a mottled pattern. Clusters of stars glowing blue-white are scattered everywhere on the disk, and we can see that the star-forming regions are spreading in a patchy manner. Also, the bar-like structure extending to cross the center is an important feature. This structure is thought to play a role in efficiently carrying the gas of the disk to the center and promoting star formation near the galactic center. The November page features the planetary nebula NGC 6072, captured in near-infrared by the James Webb Space Telescope. A planetary nebula is a celestial body formed when a star with a mass about that of the Sun ends its life, releases its outer layer into space, and that gas and dust spread. As a star grows old, it blows out a large amount of material from its surface, and eventually, the star remaining in the center becomes high temperature and illuminates the surrounding gas, causing the material that was once part of the star to appear as a glowing cloud. What stands out in this image is that the flows of gas ejected from the center extend in different directions. Instead of expanding uniformly in one direction, complex formations are created by the overlapping of gas ejections from different orientations. Such gas ejections in various directions are thought to be influenced by the presence of a companion star nestled near the central star, or by bias due to the star's rotation. The December page is the Spiral Galaxy NGC 1961, captured by the Hubble Space Telescope. It is located in the direction of the constellation Camelopardalis, about 190 million light-years from Earth. The greatest highlight of this galaxy is that its elegant spiral arms are slightly distorted. Spiral arms originally extend in orderly arms along the rotation of the disk, but their shape gradually becomes disturbed due to the influence of gravity from nearby galaxies or remnants of past approaches or mergers between galaxies. The appearance of one side of the arms being emphasized and the slight shift in the center tell the story of the turbulent history this galaxy has followed. In the disk floating in the jet-black universe, small blue-white sparkling grains of light are scattered here and there. This is a sign that new stars are being born one after another in locations where gas is abundant. On the other hand, the dark dust band running near the center shows that it is filled with rich materials to nurture the next generation of stars, even while blocking the light from behind. By looking at the distortion of such a formation together with the bias of the places where stars are born, we can perceive the grand operation of how a galaxy changes its appearance over a long period while interacting with its surrounding environment. The final image is a section of the outer edge of the exceptionally massive Tarantula Nebula within the Large Magellanic Cloud, a companion galaxy to the Milky Way, captured by the Hubble Space Telescope. The Large Magellanic Cloud is known as a precious place where the birth of stars occurring outside the galaxy can be observed in detail from a relatively close distance. The protagonist of this image is not the dazzling star cluster itself, but the faint veil of gas trailing around it and the dust band emerging like a deep shadow. While the clumps of dust block the light from behind and appear as dark streaks, the surrounding gas is heated by the light of young and sturdy stars, edging the outlines of the clouds with soft light. At first glance, it appears to be enveloped in silence, but the intense light and stellar winds emitted by massive stars born in the center constantly push outward, carving the clouds or compressing them to create new formations. Observations in the Large Magellanic Cloud, which has an environment different from the Milky Way, become a major clue to unlocking the differences in the conditions under which stars are born. As we have seen, while the performance of the James Webb Space Telescope is being demonstrated, the Hubble Space Telescope also continues to acquire data on the front lines. In 2026 as well, the overwhelming performance of these two telescopes is expected to help unravel the mysteries of the universe. Thank you for watching, and I'll see you in the next video. If you enjoyed this video, please don't forget to give it a thumbs up. Hit the subscribe button and the notification bell icon, so you'll be notified when new videos are released.